The inventions of the ancient Greeks, the spinning jenny, conveyor belt assembly, the transistor, and the first industrial robots all combined to form a worthy source of inspiration for the creative power of engineers and businessmen alike who longed to make a real breakthrough. In the Western world, there were those who opposed automation. It was feared that robots would take away people's jobs. But in the 1960s, robots weren't flexible enough to form a strong alternative.
And I would say it was not until the middle of the 1970s where you could really see that the industry started to get mature. I'm talking about the industry producing industrial robots, and the first customers had the confidence in investing in robots.
Following in the footsteps of robot pioneers such as Joseph Engelberger and his company Unimation were companies such as ASEA that invested huge sums in robot development.
But this was done at a great speed. We had about 10 months to create a first model, because there was going to be a board meeting, and Marcus Wallenberg, who was the business leader in Sweden, was expecting us to have a prototype at that time.
ASEA's robot was electrical and was run by microprocessors. The program required a capacity of 8 kilobytes, which can be compared with today's systems, which are 2,000 times bigger. Something else that was new was that it resembled a human arm. This robot was put on the market in 1974 and was to become a model that the entire industry would follow. ASEA tried without success to get big companies to buy the new robot. The daring pioneer turned out instead to be a small company, Magnussons in Jena.
Ja, vi hade ett nålsöga i produktionen, och det var slipning och polering utav rostfria rörvinklar. För att vi kunde inte få tag på folk, och jobbet var mycket skitigt och monotont. Och då hade min verkmästare kontakt med en ASEA-försäljare som berättade att de höll på att utveckla en robot som skulle kunna utföra de här arbetena. Så jag åkte till ASEA och fick se roboten som inte var färdigutvecklad helt. De saknade ett chip. Men jag frågade vad den kostade och visste ingenting, så jag fick köpa roboten utan att veta vad den kostade. Och första året så tillbringade jag många timmar om dygnet för att säkerställa kringutrustning, utveckla kringutrustning och så vidare. Så att den kunde bli helt obemannad. Och det är den första elektriska robot som går obemannad drift dygnet runt.
In their haste to create a powerful industrial robot, however, ASEA forgot to patent important components in the design.
When we had the first one out on the market, pretty soon after that, especially Japanese competitors came, quite a few. A bit other colors, but the same concept. And that, in a way, that irritated us, because we realized that you cannot really patent the human arm design. You have to patent a particular product feature. So it was a bit difficult, and we felt it was a problem.
At that time, maybe same timing, Yaskawa and ABB developed electrical type robots.
Now, after more than 25 years, now we feel more proud. I would have to say that this became the leading concept.
ASEA painted its robot orange. Yaskawa made its robot blue, and Fanuc its reddish yellow. The war of colors was on. In Japan, robots were greeted with open arms. One possible reason for this lies in the Japanese culture, which is based on animism as expressed in the Shinto religion. Here one finds myths of Sumari swords endowed with souls. Also, one finds Japanese comic strips such as Astro Boy, where robots are heroes who save the world from evil villains and extraterrestrials.
Many Japanese people think robot is a friend. Robot help human people.
These people at coffee break, they put their coffee down, take a rag, and they polish the robot. And if the robot doesn't work, it's a mark of dishonor.
In 1982, there were 250 robot manufacturers in Japan. And since the robot industry in the United States nearly died out in the 1980s, the competitive war today is between Japan and Europe.
First of all, the Japanese economy expanded very fast in the 1960s, 70s, and 1980s, and there was an optimism in the Japanese economy. And there was a labor shortage. So the Japanese, they automated basically everything that was possible to automate. Japan was the mecca of automation. It has now moved more to Europe.
Today, there are 750,000 industrial robots installed around the world. The automotive industry is by far the biggest user.
If I had known at that time that robots almost 30 years later would not only have the same color, but basically look the same, and the main application of the early 70s, spot welding on cars, is still the main application, I would just not have believed it. If I had believed it, I would have been extremely disappointed. And what I mean by that is that concept-wise, the development has been going rather slow. Business-wise, it has increased quite a bit. And it's been a long time now a task for us to try to expand that.
So Henry Ford's man-eating production line has been transformed into a flexible line of robots, with only a few people there to watch over things.
Väldigt mycket utav det som robotiseras idag är ju kopplat till bilindustrin som just har de här stora volymerna, som har årsmodellvariationer, som har och under lång tid också haft väldigt mycket kompetens för att automatisera. De här sakerna tillsammans har ju drivit fram stora applikationer inom punktsvetsning och bågsvetsning, limning, olika materialhanteringsapplikationer där just bilindustrin har varit ledande. Ett område som EU satsar på nu, det är ju livsmedelsindustrin med robotar för speciella behov inom den marknaden, och där hastighet och snabbhet är än viktigare än bilindustrin. Dagens robotar och robotteknik kännetecknas ju av att robotarna kan kommunicera med omgivningen på ett mycket bredare sätt än vad vi kunde i början.
And even in the robot manufacturing industry, attempts are being made to realize that old dream, robots that produce robots.
Of course, now in the production, maybe 30% we are using robot for the manufacturing. But the near future, maybe 50%, 60%. Anyway, we will use the robot for the production more, but not 100%.
We have entered the robot era, an era where man increasingly lets his technological creations produce the products he needs or thinks he needs.
In Europe, in 2015, we will have an enormous crisis because we will have a very large share of the population in the age below 18 and in particular above 60 years old. And we will have a small population that is active. And the question is, how will this small active population be able to support this large share of old people and in the same time produce the goods and services that we need?
I think we have good reasons to foresee a very positive future in the robotics business, for various reasons. First of all, if you take a key figure like the amounts of robots per thousands of workers in manufacturing industry, you could say that automotive is around 50 robots per thousand workers, whereas the average of the industry is something like 15. That in itself guarantees for a huge potential of robotics equipment. But also new areas will be automized in the next years to come.
In many low-wage countries, where there is a large labor force, robots have not yet won widespread acceptance. There, the combination of traditional working methods and the ability to change rapidly is still in direct competition with robots. Many factors affect the choice. Will robots become our helpers or our competitors? This question is just as important today as it was when the English workers smashed the looms in the beginning of the 19th century. Their philosophy is kept alive today by the Neo-Luddites.
And I pulled out a big computer, and I bought a sledgehammer, a nice big sledgehammer, the kind that the Luddites had used when they broke machinery. And I smashed it into this computer, and it broke in such a satisfying way, I can't tell you. I don't know how lethal the chemicals were that came out of that computer, but it looked good, I can say that.
The question of whether robots are good or bad is not really a big question now at all. It depends on how you use them. It's like every tool you get makes you more possibilities. If you use them in the right way, fine. If you use them in the wrong way, you can screw up anything.
There are, however, areas where most people are in agreement regarding the advantages of robots over humans. In dangerous working conditions, such as detecting landmines, disarming bombs, or the exploration of the surface of other planets.
Galileo is on its way to another world. It's in the hands of the best flight controllers in this world. Fly safe.
A lack of time is used as an argument for the development of technological innovations for use in the home. And in Japan, where there is very little free time and it is difficult to take care of live pets, a robot dog, Aibo, has become a big seller. It is capable of recognizing the human voice and understanding its surroundings.
Aibo.
Each dog has a unique personality which is formed by the environment it grows up in.
Aibo を実際買ったおばあちゃんかなんかが名前を全部つけてで一生懸命可愛がってて、それでどっかお参りに行った時に一緒に連れてって一生懸命可愛がってるのを見た時に本当の犬みたいに自分の子供みたいにしてるんで、そういうふうに実際普通の人は接するのかななんていうふうなことを言ってましたね。
Far more controversial than Aibo are the robots used in healthcare and home nursing. This is where the robot industry has met the strongest resistance when it has tried to persuade people of the advantages of robots compared to the care given by humans. The Japanese, even here, are the most positive.
そうですね。まず、今回アトムという キャラクターがあって、あるいはロボットっていうのは非常に日本の中ではポピュラーになってますよね。そういう意味で日本人はある程度受け入れやすい環境にあるかなというふうには思います。それから先ほどおっしゃったようにロボットに直接面倒を見てもらうというのは、私自身もそれは考えていて、今の段階では多分難しい問題がかなりあると思います。でやはり人をケアするんであれば、やっぱり生の手で優しい声でちゃんとしたケアをするのが本筋だと思うんですよね。ですから今考えているのは、ASIMOがそれをやる人の後ろにいてですね、その人をサポートしてくれる、そういう段階かなというふうに思ってます。で自分が年を取った時に、動けなくなった時には自分が作った ASIMOにお願いするのは、それは多分できると思うんですよね。でそういう意味で時代がある程度変わっていって、ロボットが普及されて使いやすくなっていけば、ある程度のそういった境目っていうのはグレーになっていくかなというふうに思います。で今の段階ではやはりおっしゃる通り、その辺はちゃんと考えて、使い方っていうものを何でもできるよっていうんじゃなくて、こういうことを注意してやっていかなきゃいけないんだよってことを我々がいつも意識してなきゃいけないかなというふうには思いますけど。
Costs in health care and care of the elderly are constantly rising, and many robot experts mean that efficient robots have a place in these sectors. With the help of robots, medical specialists can examine patients and perform operations remotely.
I mean, there's no question that a robot is extremely much more efficient than a surgeon in helping with changing a hip joint on a patient. Because a robot, a doctor that is going to drill the holes in the bones for fitting mechanical parts, he should have had a training as a carpenter, and he does not have. A robot that sees the X-rays from 2 or 3 sides on the patient can do this extremely accurately.
Robots could also help senior citizens with simple healthcare routines in their own homes.
I happen to live in Florida, which probably has the largest population of elderly people in the United States, and between the cost of nursing home care and the fact that people want to remain in their homes because of the questionable care they may get in a nursing home, I think that this is one of the prime areas and initial areas for robots and robot care.
Everyone then lives in fear that they're going to end up their days in a nursing home. And that's a terrible prospect, because you're going to be sitting in a wheelchair smelling urine for the rest of your days. So we're saying that we could put this robot in the home with the person. It would fetch and carry. It would help you out of bed. If you're going someplace, it would take your arm and help walk you so you don't fall.
But there are still many problems to solve before robots can be used to any extent within healthcare.
To use a robot as a home, we have to solve a lot of technology problem, robot function and also safety problem. So this is my opinion. If we keep some distance between human and robot, so we have possibility to utilize a robot many things, but very close, little bit dangerous.
Hello, Kismet. You gonna talk to me?
Another problem is the psychological factor. One way of reducing people's fear of robots is to make them more human in appearance, humanoids, so to speak, which could be self-teaching and resemble humans both in appearance and movement.
I was interested in how people would interact with robots, and by having the robot have human form, people would treat the robot somewhat like they would treat a human, and then engage in normal social sorts of interactions, such as making eye contact, nodding, smiling, giving expressive facial expressions, which they wouldn't do to a more traditional robotic arm and camera sitting there disembodied.
We see here is a demonstration of the saccade to motion routine, which simply put is when there's movement in the scene, in this case Brian moving his hand around, then Cog turns its eyes to look directly at it. And the way that works is we have a motion segmentation routine, which you see here is the camera, Cog's camera, and the boxes are being drawn around where there's perceived motion in the scene. And this motion information is sent to a second routine, which has learned previously how to move the eyes.
There's one camera that has a very wide field of view, a peripheral vision, and one camera that has a very narrow field of view, but high resolution in the center. The best way to see this is by looking back on the monitor screen to see what Cog can actually see. On the far right, you can see the wide field of view for detecting motion in the periphery, and just next to it, you can see the foveal camera, which gives you a high resolution image of just a certain part of the visual field.
And because the system is feedback, it's not some sort of explicit program that I wrote, it means that it can respond to things like me stopping it and letting go and very quickly settle into driving the system in the right way.
In the future, the design of humanoids may reach the stage where it will be difficult to tell what is human and what is artificial.
A robot could be much the same as a human being. And we are machines, we are biological machines made of biomolecules. So in principle, I think we could make a machine out of other components besides biological components, which would be just as good or as capable as a human. Now the question is whether we humans are smart enough to build such a robot.
I'm not quite sure. I love you. Aw, did he say he loves me? I love you too.
With all of that effort on giving heads on the robot, getting it to smile at you and let it to say it's unhappy, I don't care whether the robot's happy or unhappy, as long as it works reliably for me.
Trying to make robots that look like humans, move like humans, to me does not yet make very much sense. I think that is, it's not an efficient way of research money. It's easy for our creator to make humans with 2 legs and 2 arms, then we can move in stairs and so on, but it's very difficult to make robots that can do that.
But what then will the future be like? Will there be any people at all working in our factories? Will robots be taking care of our old people, performing surgery and acting as pets? Will robots be the tools of the poor and human help a luxury that only the rich can afford? What influence will robots exert on our lives and our relationships?
I do believe that women will be big users of robots as companions. But it is women perhaps that will want the expertise of sexual techniques, perhaps.
You need to resist the power of any technology from taking over your life and making you a slave to it, making you the tool instead of it being the tool.